Hi, welcome to our next lesson on recursion in Python. In our previous lesson, what we saw was how we can implement the factorial operation in Python by using the recursive approach. Right now, what I want to focus on is to go deep into this recursive function and explain to you what is actually happening as we call ourselves recursively step by step. Okay, and as you can see towards the end of this program, the output that we're going to print out is actually very clear in showing you exactly what is happening. All right, so let's get started. So this is our factorial function that we have already developed. Now I'm just going to modify this now. For the input parameters, I'm going to pass in one more parameter called depth. Okay, so the initial depth will be 1 that is modified here. And now what I'm going to do is, for the exit condition when n equals to 1, I'm going to do a print, and the print would be based on the depth of where I am in the recursion. And to show that very clearly, I'm going to use tab spaces. Okay, so I'm going to print tab multiplied by the depth. Okay, so this will actually print as many tab spaces that are needed based on the value of the depth parameter here. Okay, and every time I call myself recursively, I'm going to modify this depth value here. Okay, so let's do this. And I'm also going to print one more string here called returning 1, so that I know that I've reached the exit condition when my n is equals to 1. Now, for the else condition, which is what we are going to execute for the rest of the recursive callbacks, okay, we are going to be, I'm going to do one more print here. So print, again, I'm going to do the same thing, which is the /t multiplied by the depth, okay, followed by one more statement here, recursively calling factorial. Okay, I'm going to put an open bracket here, and what I want to do is I want to print the value n minus 1, okay, and then close the bracket here. Okay, and this is the result that I compute, and I want to also print this result over here. So I'm going to do a print. Okay, so I'm going to do the same /t multiplied by depth, so it's at the same tab space as the previous statement, and I'm going to print returning result. Okay, and as I mentioned just now, we have an additional variable called depth, okay, for this function. So when I call myself factorial, the n is being decremented, but the depth, okay, is incremented, because each time I increment my depth, that is telling me that I'm going one more level deeper into the recursion. Okay, and then I print the result. Okay, so that's about it for the changes that I'm going to do. Okay, so we have completed the program already. Now I'm just going to run this code and let's see what happens. I'm going to run module here. Okay, as you can see, the printout, like I said, is very intuitive. We are passing in a value of 5, all right? So when I call myself recursively the next time, the n minus 1 has decreased and depth has increased. So that is why I am actually moving in that one tab space at a time. So every time I call myself, as my n value is decreased, my depth value is increased until it reaches a value of 1. When I reach a value of 1, that is when I start to return values. Okay, so the very first time is 1. Subsequently, when I go back, it is 2 times 1, so I get 2. Then when I come back, it is 3 times 2, which is 6. Then when I come back one more time, it is 4 times 6, which is 24. And the last time is 5 times 24, which is 120. So the factorial of 5 is 120. So as you can see from this printout, it is very clearly shown how the recursive calls are being made and at which point the values are starting to return back, okay, to the previous functions as we roll backwards to the starting point where we first started, we first called the function factorial. All right, so I hope this has given you a good idea, okay, on how the recursion actually works, step by step, layer by layer. Okay, so this is again a very important thing to understand, because recursion can be very useful in solving some very complex algorithms, okay, that you wish to implement in your code. Okay, so it's a good technique to learn, but always remember to make sure you put in a proper exit condition so that you do not end up with a infinite recursive call. All right, thank you for watching, and I will see you in my next lesson. Thank you. Bye.